हेलो वेलकम। आज हम देखेंगे कि एनपीटीएल इथिकल हैकिंग का वीक 7 असाइनमेंट नंबर 7। सो क्वेश्चन नंबर 1, कंसीडर ए हैश फंक्शन h that generate hash values h1 and h2 when fed with message m1 and m2 respectively. Which of the following options can never be true? Can never be true means okay. सो इसका आंसर हो जाएगा ओके ऑप्शन नंबर बी. So let's analyze each statement. Statement A, H1 and H2 are equal, but M1 and M2 are unequal. Okay. This statement implies that two different messages, that is M1 and M2, okay, produces the same hash values H1 and H2. This situation is known as a collision in hash function, where two different inputs generate the same output. Collisions are possible with most hash functions, especially those used in cryptography, because the number of possible inputs is far greater than the number of possible hash outputs. So therefore, this statement can be true. Okay. So a true statement है H1 and H2 are equal, but M1 and M2 are unequal. Okay. This is all about. Statement B, M1 and M2 are equal, but H1 and H2 are unequal. Okay. So this statement implies the same messages M1 when hashed twice produces two different hash values, that is H1 and H2. This would indicate that the hash function is not consistent, which violates a fundamental property of hash functions, determinism. Okay, a hash function should always produce the same hash value for the same input. Therefore, this statement can never be true. Okay, so this statement false. Okay, so option number B. Option number B can never be true. Okay. Question number 2. What is meant by collision in context of hashing? Okay. So इसका आंसर हो जाएगा ऑप्शन नंबर ए. ओके. ऑप्शन नंबर ए, that is option number A, that is in context of hashing a collision occurs when two different input messages, अभी हमने देखा था क्वेश्चन नंबर 1 में, produce the same hash value. Hash functions are designed to map data of arbitrary size of fixed size values or hashes. Ideally, each unique input should produce a unique hash. However, since the output space is finite and the input space is usually much larger, so collisions are inevitable. Okay, collisions are inevitable due to the pigeonhole principle. Okay, pigeonhole principle. So option A, this is correct because it describes the definition of a collision. Multiple distinct messages produce the same hash value. Okay. So option A should be true क्योंकि more than one different messages can generate the same hash value. Okay. ऑप्शन ए ट्रू हो गया. ऑप्शन बी false because it describes scenario related to encryption, not hashing. In encryption, two different plain texts having the same hypertext would imply a problem with the encryption algorithm, not a hash collision. Okay, so option B false. Option C, this incorrect because it describes a specific output, all zeros, rather than a collision. A collision refers to two different inputs mapping to the same output regardless of what output is. Okay, so इसका करेक्ट ऑप्शन हो जाएगा ऑप्शन नंबर ए. ओके. क्वेश्चन नंबर 3, which of the following does not corresponding to the fast premise resistance in the context of hash function? Okay, so fast premises कौन कौन सा corresponding नहीं करता है, तो इसका आंसर हो जाएगा बी सी. ओके, बी सी, बी एंड सी. सो बी सी, दिस गिवन मैसेज यहाँ पे एक्सप्लेनेशन नहीं होगा. and this is not the false premises. BC okay, explanation नहीं होगा कि false premise resistance is a property of hash functions that makes it difficult to reverse engineering a hash value to its original input. Specifically, it should be computationally infeasible to find any input m that maps to a specific hash value h. Let's break down each option. Option A, this statement correct, describes the false premises resistance because it emphasizes the difficulty in finding a message m that produces a specific hash value h. This is directly aligned with the definition of false premises of resistance. So option A false premises और 2, 3 false premises नहीं है. Only option A is the false premises resistance. So BC false premises resistance है ही नहीं. Okay, BC. So ऑप्शन बी देख लेते हैं. ऑप्शन बी डिस्क्राइब सेकेंड प्रेमिस रेजिस्टेंस. ओके, not first premise resistance. Second premise resistance means that given one message m1, it is difficult to find another message m2 such that their hash values are the same. That is hash m1 equal to hash m2. इसको याद रखो. ओके, कौन कौन सा फर्स्ट प्रेमिस रेजिस्टेंस है और कौन कौन सा सेकेंड प्रेमिस रेजिस्टेंस. ओके, so option C, this is incorrect. It is the context of cryptographic hash functions because the goal is to find messages that produce the same hash, not different ones. It seems to misunderstand the fundamental concept. It should not be difficult to find two messages that produce unequal hash values, since most distinct messages would naturally have different values. Means different hashes. Okay. So option B, C do not correspond to fast premise resistance in the context of hash function. Okay, इसको याद रखो. Option A, that is option A only fast premises. Okay, and ये जो B C option है second ये only देखो option A is the fast premise resistance and option B second. Okay, और C ये cryptographic hash function है. Okay, इसको याद रखो. कौन कौन सा fast premise resistance, कौन कौन सा second premise resistance. Okay, so यहाँ पे A option fast premise resistance. Okay, and B that is second, and ये B C इसका आंसर होगा. Okay, so question number 4, which of the following either are false for on-keyed hash function, that is modification detection code MDC. Okay, so इसका आंसर हो जाएगा ऑप्शन नंबर बी. ओके, इसका आंसर हो जाएगा ऑप्शन नंबर बी. तो on-keyed hash function, also known as modification detection code, are used to ensure the integrity of the data by producing a unique hash values from the input data. So they do not involve any secret keys for or authentication mechanisms. Let's evaluate each option. Option A, this is true. That is on-keyed hash function preserve the integrity of the message by generating unique hash value, allowing verification that the message has not been returned. Option B, this is false. On-keyed hash functions cannot authenticate the source of a message because they do not involve any secret keys or mechanisms to verify the sender's identity. Authentication requires keyed hash function, okay, such as HMAC, that is hash-based message authentication code, which incorporate a secret key. Okay, option C, that is true. On-keyed hash functions generate output that depends solely on the input data, not on any external keys or additional data. So false हो जाएगा ऑप्शन नंबर बी. ओके, false हो जाएगा ऑप्शन नंबर बी और A C ट्रू है. ओके, ओनली ऑप्शन नंबर बी फॉल्स. ओके, यस. क्वेश्चन नंबर 5, which is the following statement is true. ओके, तो ट्रू होगा एनक्रिप्शन realizes one-to-one mapping. ओके, एंड सी ऑप्शन हो जाएगा हैशिंग realizes a many to one mapping. ओके, सो इसका एक्सप्लेनेशन भी देख लेते हैं. ऑप्शन ट्रू होगा 5 का बी सी, और ऑप्शन का भी एक्सप्लेनेशन देख लेते हैं. ओके, देखो, to understand these options, it is essential to grasp the fundamental difference between hashing and encryption, particularly regarding how they map inputs to outputs. Okay? So option A, hashing realizes a one-to-one mapping. Okay, this is false. Okay, hashing does not realize a one-to-one mapping. Okay, because multiple distinct input can produce the same output, known as collision. This characteristics is a many-to-one mapping, not one-to-one. Okay, so hash functions map a vast range of possible inputs to much smaller set of possible outputs, that is hash values. Option B, encryption realizes one-to-one mapping. This is true. Encryption designed to be a reversible process with a one-to-one mapping between plain text and ciphertext. When a specific key is used, each unique input, that is plain text, has a corresponding unique output, that is ciphertext, given the same encryption key. So ensuring that the process can be reversed during the decryption. So option C, hashing realizes a many-to-one mapping. This statement is true. Okay, hashing realizes a many-to-one mapping. This is true. Hash functions inherently have a many-to-one mapping because different inputs can produce the same hash value, that is collision, especially given the finite size of hash outputs. Okay. So option D, encryption realizes a many-to-one mapping. This is false. Encryption does not realize many-to-one mapping because each distinct input with the same key produces a unique output, maintaining a one-to-one correspondence. Okay. So correct statement B and C. Encryption realizes one-to-one mapping and hashing realizes a many-to-one mapping. Okay. So इसका आंसर हो गया ट्रू बी एंड सी. ओके, एंड इसका एक्सप्लेनेशन नहीं होगा. एंड क्वेश्चन नंबर 6, which of the following a hash function? Okay, so hash function हो जाएगा MD5 and SHA1, A and C. okay ना, MD5 and SHA1, that is the hash functions A and C. yes. So explanation नहीं होगा कि hash functions are algorithm that take an input or message and return a fixed size string of bytes, typically a digest that is unique to each unique input. They are primarily used for data integrity, digital signature, and other security applications. Here the explanation for each option. Option A था MD5. MD means message digest algorithm 5. So MD5 is a widely used hash function that produces a 128-bit hash value despite being considered insecure due to vulnerabilities that allows for collision. It is still recognized as a hash function, therefore this is correct. Option B, that is triple DS, that is triple data encryption standard. So triple data encryption standard is an encryption algorithm, not a hash function. Okay, so it is an encryption algorithm, not a hash function. So it uses 3 iterations of the DS encryption algorithm to enhance security, but does not produce a fixed size hash. Instead, it encrypts and decrypts the data. Therefore, this option is incorrect. Option C, SHA1. SHA means secure hash algorithm 1. So, secure hash algorithm 1 is a cryptographic hash function that produces a 160-bit hash value despite being decrypted due to security vulnerabilities. Okay, security vulnerabilities. It is still classified as a hash function. Therefore, this option is correct. Option D, AES means Advanced Encryption Standard. AES is a symmetric encryption algorithm, not a hash function. इसको याद रखो. It is a symmetric encryption algorithm, not a hash function. It is used for encrypting and decrypting data rather than generating fixed size digests. So, therefore, this option is incorrect. Correct option is MD5 and SHA1. Yes. Question 7. Hash functions are slower as compared to symmetric and public key encryption. This is false. क्योंकि hash function is faster. Okay, not slower. Hash function is faster. This is not slower. It is faster. So false हो जाएगा. तो इसका explanation नहीं होगा कि hash functions are generally faster compared to both symmetric and public key encryption algorithm. Okay, here are the detailed explanations. Okay, हैश फंक्शंस क्या है? हैश फंक्शंस such as SHA 256, SHA 3 and MD5 are designed to quickly generate a fixed size output that is hash from any input data. They are optimized for speed and do not involve the complex key management or encryption diffusion process required by encryption algorithm. Okay, so hash functions operate on data in a streamlined manner, processing such speed of the input efficiently to produce hash value. Okay, symmetric encryption क्या है? Example AES. Okay, it is a symmetric encryption involves more computational steps, including key expansion, multiple rounds of substitution, and permutation operations. While symmetric encryption is generally faster than public key encryption, it still involves more complex operations than hashing. Okay. So public key encryption example क्या होगा? RSA and ECC. So public encryption algorithms are significantly slower because they involve complex mathematical operations like modular expansion. Okay, क्या है? Mathematical operations like modular expansion and are designed for secure key exchange rather than speeds. Okay, so इसका आंसर हो जाएगा ऑप्शन नंबर बी, that is false. Hash functions are faster, not slower. Okay, it is false. Due to for this reason, it is false. Okay. Then question number 8. What are the block size and key size of the DES algorithm? That is A option 64 bits and 56 bits. Block size is 64 bits and key size is 56 bits. Okay, in DES algorithm. Okay. तो ऑप्शन नंबर 8. तो इसका explanation यही होगा कि the DES, that is data encryption standard algorithm, operates on data blocks of 64 bits. This means each chunk of data processed by DS, that is 64-bit long, and key size 56 bits. Although DS key is technically 64-bit long, only 56 bits are used directly for encryption. The remaining 8 bits are used for parity, that is error checking purposes. Okay, effectively making the encryption key size of 56 bits. Okay, so therefore DS has a block size of 64 bits and key size 56 bits. Okay, so इसका आंसर हो जाएगा ऑप्शन नंबर ए. Then question number 9. Which of the following are true for digital signature? So digital signature is legally equivalent to handwritten signature. Okay, option number A. And option number C भी हो जाएगा. B नहीं होगा, C होगा. Anybody have accessing to the signer's public key can verify its signature. That is option number C. Okay, so correct option number A and C. So इसको एक्सप्लेनेशन देख लेते हैं कि ऑप्शन ए डिजिटल सिग्नेचर इज लीगली इक्विवेलेंट टू हैंड रिटन सिग्नेचर. दिस स्टेटमेंट इज ट्रू इन मेनी circumstances where digital signature are legally recognized and have the same legal standing as handwritten signatures. Okay, option B, in digital signature signer uses public key to sign. It is false. Okay, to be false, a digital signature is created using a private key of the signer, not the public key. So the private key is kept secret while the public key is used to verify the signature. Option C, anybody having access to the signer's public key can verify the signature. It is absolutely true because the verification of a digital signature is done using the signer's public key, which is publicly available. Okay, so this allows anyone to verify the authenticity and integrity of the signed messages. Okay, so option A and C true है. Okay, question number 10. The SSL record protocol is responsible for none of these. Okay, none of these. Option number D. Okay, तो इसका ऑप्शन नहीं होगा. तो SSL record protocol uses a combination of various cryptographic techniques to provide secure data transmission over the network. It ensures data encryption and also data integrity. Okay, data integrity using hash functions. However, it does not provide authentication service or non-repudiation guarantee. Okay, it does not provide the guarantee, that is authentication service or non-repudiation guarantee. Okay, so इसलिए ऑप्शन नंबर डी हो जाएगा इसका आंसर. सो मिला लेते हैं एक बार. क्वेश्चन नंबर 1 का बी, यस। क्वेश्चन नंबर 2 का ए, यस। क्वेश्चन नंबर 3 का बी सी, यस। क्वेश्चन नंबर 4 का बी, यस। क्वेश्चन नंबर 5 का बी सी, यस। क्वेश्चन नंबर 6 का ए सी, यस। क्वेश्चन नंबर 7 का बी। क्वेश्चन नंबर 8 ए। क्वेश्चन नंबर 9 ए सी। क्वेश्चन नंबर 10 that is D. Submitted successfully. Okay. Thank you.